Hello friends, welcome back to our channel. So in this video we will be covering exercises of chapter 10 work and energy. So firstly, when work, first question is it's about when work is done or not. So we know that in the previous video we have learnt about when work is positive, negative, and when it's zero. It's positive when the direction of force and displacement are the same, and then when they are opposite the work done is negative, and when there is displacement not caused because of force, which is perpendicular displacement to the force direction, gives us work done is equal to 0. So here Suma is swimming in the pond and giving an force in the front, and her displacement is also in the front, so work is done. A donkey is carrying a load on its back, so here no work is done because force is exerted in the upward direction and the displacement isn't there, so the displacement is equal to 0, so work done is equal to 0 2. Windmill is lifting water from a well. The displacement and force direction are same, which is upward, so work is done. Green plant is carrying out photosynthesis, no force or displacement is happening, so 0 work. An engine is pulling a train. Here displacement and force direction are equal, which is on the right side, so or the left side, so work is done. Food grains are getting dried in the sun. Here no force or displacement is done, so 0 work. A sailboat is moving due to wind energy. Here work is done and the force direction, displacement direction are same. So let us move on to the next question, which tells us about an object thrown at a certain angle to the ground moves in a curved path and falls back to the ground. The initial and final points of the path of the object lie in the same horizontal line. What is the work done by the force of gravity on the object? Here the force of gravity of the object doesn't work at all because the displacement is in the right direction, and force is coming in the perpendicular direction, which is upward direction. So work done by the gravity is equal to 0. A battery lights a bulb. Describe the energy changes involved in the process. Here, first chemical energy, which is in batteries, converts into electrical energy, and then it is converted into light and heat energy, which is exerted by the bulb. Curtain force is acting on a 20 kg mass, changes its velocity from 5 to 2 meter per second, which is its speed. So calculate the work done by the force. So here the work done will be expressed by the following ways. First, let me show you the answers that I have written of the initial questions. Here the answers, and then comes of third question here, and then fourth question. First, we will write given mass, initial velocity, and final velocity. As we know that work done is equal to energy consumed. Here kinetic energy is there, and work done is equal to change in kinetic energy, so we will calculate it till it comes the answer to be minus 210 joules. The answer is in minus because there is an deceleration force acting upon it, so the work done is also in negative, as the force is in this direction and displacement in this direction, so both are in opposite directions, letting us the work to be in negative. So moving on to the fifth question, which is about a mass of 10 kg is at point A on the table. It is moved to point B. If the line joining A and B is horizontal, what is the work done on the object by the gravitational force? Here, and the gravitational force is perpendicular to the displacement, so work done is equal to 0. Sixth question. The potential energy of a free falling object decreases progressively. Does this violate the law of conservation of energy? No, it doesn't violate the law of conservation of energy, because as the height decreases, the kinetic energy increases because the velocity increases. What are the various energy transformation that occur when you are riding a bicycle? So basically, the muscular energy that we are exerting onto the pedals gets converted into mechanical energy, and the heat that gets into our body. Sixth question. Does the transfer of energy take place when you push a huge rock with all your might and fail to move it? Where is the energy you spend going? Here, the transfer of energy takes place because our muscular energy comes into ourselves only as heat energy. Then next question, a curtain household has consumed 250 units of energy during a month, and how much energy is this in joules? So we know that 1 unit is equal to 1 kilowatt, which is equal to 3.6 multiply 10 raised to the power of 6 joules. So we will calculate it to 9 multiply 10 raised to the power of 8 joules, which is 90 crore joules. Then 10th question, an object of mass 40 kg is raised to the height of 5 meter above the ground. What is its potential energy? If the object is allowed to fall, find its kinetic energy when it is halfway down. So here mass is equal to 40 kg, height is equal to 50 meter. Potential energy is equal to 2000 joules, which is 2000 joules. By the law of conservation of energy, potential energy lost is equal to kinetic energy gained. So it halfway, and the h, which is height, becomes half. So potential energy becomes 1000 joules. So and kinetic energy also becomes 1000 joules according to the law of conservation of energy. Next question, 11th question. What is the work done by the force of gravity on a satellite moving around the earth? Because the force of gravity is perpendicular to the displacement of the satellite, because always we consider the tangent of a circle orbit of an object as in its displacement, so the work done is equal to 0. Can there be a displacement in an object in the absence of a force acting on it? Yes, this can be done because during an uniform motion this can happen, because the net force is equal to 0 and there is displacement. A person holds a bundle of hay over his head for 30 minutes and gets tired. Has he done some work or not? Justify your answer. Yes, the person has done zero work because he has hold his bundle of hay for 30 minutes, but there was force but no displacement. So work done is equal to 0. An electric heater rated 150, meaning 1.5 thousand watt. How much energy does it use in 10 hours? So given power is equal to 1.5 kilowatt, we will calculate it into this, and we know that power is equal to energy by time. We will calculate the energy to 15 kilowatt. Then 15th question, illustrate the law of conservation by discussing the energy changes which occur when we draw a pendulum bob to one side and allow it to oscillate. Why does the bob eventually come to rest? What happens to its energy? Is it a violation to the law of conservation of energy? So we will explain it through this the pendulum example only, where we have taken the main position as O and leave the bob at A. Here the potential energy at point A and B will be the highest, while at O the kinetic energy will be the at B the kinetic energy will be the highest when the bob is leave from point A. So here no violation of the energy conservation is occurred. So this is a very nice example. You can write this on in your exam also. Next question, an object of mass m is moving with the constant velocity v. How much work should be done on the object in order to bring the object to rest? Because we have applied a curtain force over it, so we have to apply the same force in negative direction so that we can make the object to rest. Calculate the work done to stop a car of 1500 kg moving at a velocity of 60 km per hour. Firstly, we will calculate the 60 km per hour into meter per second. So here we have calculated it and got it 50 by 3 meter per second. So kinetic energy comes to be 208,333.3 joules. We have calculated it very easily, and this is equal to 2,08,333.3 joules. Then 18th question that tells us about the same. So you will post this answer in the comment box, and we will move on to the 19th question, which says that the acceleration in an object could be zero even when several forces are acting on it. Do you agree with her? Why? Yes, I agree with her because she is completely right. When there is an balanced force acting on an object, F- find the energy in joules consumed in 10 hours by 4 devices of powers 500 watt each. So each will cover 500 watt is equal to 0.5 kilowatt, which calculates to 5 kilowatt because 10 objects are using that. We can multiply it by 4 so that we can get the answer to be 20 kilowatt. A free falling object eventually stops on reaching the ground. What happens to its kinetic energy? Kinetic energy gets to zero at the point reaching the ground, and it converts into heat and sound energy while touching the ground. So along with this, we have completed this video very fast, and also we have covered the whole exercise. Thank you for watching my video. Please like and subscribe my channel, and stay tuned to my channel to watch this sound chapter mind map, which is the best mind map you can ever find on YouTube. So thank you for watching my video. Please like and subscribe my channel, and do not forget to subscribe. Thank you.